So today we are doing some review of solving equations. Right? It's section P2 in your book. We're not going to do the whole section. There's way too many kinds of equations in this one section. So we are going to do for today, we'll talk about equations generally. We'll solve linear and rational equations, which they lump together in the book. And we'll solve quadratic equations by a few different methods. Stop. That's all we'll do for today. We'll save radicals and I forget what other kinds come after that, but break it into two. We have the time to do that. So equation. What do we mean by an equation? It's got an equal sign in it, right? I mean, this is the distinction that I always make is like this. If I have just 2x plus 1, darn it, 2x plus 1 without an equal sign, that's an expression, right? That's just an expression. There's nothing to solve, right? You can evaluate it. You could plug in x and see what it equals, but there's nothing to solve. So that's an expression. If it's y equals 2x plus 1, that's a function because it's actually y equals an expression. Two variables means you can't solve for either one of them. All you can really do is plug in values of x, calculate the y, plot all the points, you get a graph, right? So expressions we evaluate, functions we graph, equations we solve. Equations have some expression on the left equals some expression on the right, and we solve. Even if the expression on the right is like this, it's just 0, there's not even a variable or a constant term or anything, it's still an equation. Because why? Because that equal sign right there. So, and what do we do with an equation? We solve. Connor? Good. Right. To solve it means find the values of the variable that make the equation true. Find the values that make the left equal the right. Yeah, how you do that depends. You know, we have many different kinds of equations, and everyone has some different methods for solving. We will look at linear and quadratic only today. And then next class, we do higher order polynomials, radicals, absolute values. And that's not by far all equations, because there's logarithms, there's exponentials. At the very least, there's those. Trigonometric. Oh, you know what I was going to do? Here's the clock. Come on. I'm putting a clock up because when we have these kind of long silences like that, if you're watching the video, you'll at least see, yeah, something's going on. The clock's ticking. We're just waiting. I can't see that because I'm recording all this in QuickTime. I don't see where it allows me like to pause the recording of it. It lets you pause the playback, but not pause the recording of it. What's that? QuickTime. That thing right there. Software on the Apple. It's recording the screen, right? It's not me. You're not going to see me. You're just going to see everything that's being done here and the noise that's going on in this room. You get. Okay. So linear equations are the simplest. A linear equation, generally, ax plus b equals 0. What makes it linear? Again, this doesn't have a graph. It's not a function. But what is it that makes it linear? What is it? Close. What is it that's not being raised to a power other than 1? The x. The x, right? Because this x is being raised to the first power, that's what makes it linear. So like we had on the last screen, 2x plus 1 equals 0. You know, how do we solve it by isolating the variable on one side. The answer will be on the other side. How do we isolate? We do operations to both sides. What we called last class the properties of equality. Add the same thing to both sides. Subtract the same thing from both sides. Multiply, divide, square, square root, flip. Whatever you do the same thing to the other side. Good. Katerina, you done? Okay. Guys, save it. Okay, solve. Here's a linear solve. What operations are we going to do to both sides? Subtract what? 7. Why subtract? Because that's a positive 7, right? I've seen when there's mistakes with this kind of problem, the mistake I see most often is because you don't see a sign in front of that, but you see a minus afterwards, you think you're going to add 7. But that is a positive 7. So to isolate the variable, we will subtract 7 from both sides. Negative 2x equals 8. And then what? Divide by negative 2. So x equals negative 4. Pretty basic, right? Good with that? Okay, how about this one? Now we've got variable terms on both sides, constant terms on both sides. In order to isolate the variable, it's got to be in one place. How do I do that? Okay. Yeah, honestly, at this point, you could do one of 4 things and be right. No, in the end, you could subtract 7x, you could add 9, you could subtract 5x, you could subtract 7 as a first step, and you could still be on your way to the right answer. But what we suggest is deal with the variable terms first, and always move the smaller of the 2 variable terms in order to get them together on one side. So the smaller of 7x and 5x would be 5x. So how do you move or cancel a 5x on the right-hand side? Subtract 5x from both sides. (2x minus 9 equals 7). Then get the constants on the other side. What should I do? Ariel? Add 9. 2x equals 16. Last step. Divide by 2. x equals 8. Easy stuff. Now, you know, as the last step, what could you do? You could check. You could plug it back in and check and see when you plug in 8. 7 times 8 is 56. 56 minus 9 is 47. 5 times 8 is 40. Plus 7 is 47. Yeah, it checks. Good? Okay. Is this still a linear equation? It's linear because x is raised to the first power. In the book, they're calling this a rational equation, right? What would make it rational? The fact that you see that it's got fractions in it, right? But really, the rules that we learn to solve rational equations really kind of depend on having variables in the denominator. And we don't have any variables in the denominator. So we have some options here. We could just deal with the fractions. I mean, which is the bigger fraction, 4/9 x or 1x? 4/9 x is bigger than, 4/9 is smaller than 1x, right? 4/9 is a fraction less than 1. So I could just deal with it. 4x, subtract 4x over 9 minus 4x over 9. That gives me 1/3 equals, if I call that 9/9, that's 1. 9x over 9 minus 4x over 9 is 5x over 9. I still have the 5/3. Okay, now I need to move the constant 5/3. So what should I do? Subtract 5/3. Okay, so what's negative 1/3 minus 5/3? Same denominator. So what's negative 1 minus 5? Negative 6. So that's negative 6/3. But that's actually negative 2. Right? So we have negative 2 equals 5x over 9. So not looking at this thing here, just this part right there. How do you solve for x? It's being multiplied by 5 over 9. Okay, if you times it by 9, you would get negative 18 equals 5x. Right? So if I take all that and I multiply it times 9, I got negative 18 equals 5x. And then divide by 5. Right? So that's the answer, negative 18/5. Now, but here's the thing. Most of the time, we don't like to deal with fractions. And if it's possible, our strategy is to try to get rid of denominators in a first step. That's called clearing fractions. And the way you clear fractions is you look at what you started with. Which is this one right there. And what would be look at all the denominators that you see there, 9 and 3. What's the least common denominator? 9, right? 3 divides into 9, 9 divides into 9. What's the denominator here of x? It's 1, right? Whatever is that least common denominator, multiply everything by that. Right? When I do that, meaning multiply that, and that, and that, and that, when I multiply the first term by 9, 4x over 9 times 9 is 4x. The 9s cancel. When I multiply negative 1/3 times 9, 3 goes into 9 3 times, so that's minus 3. X times 9, there's no denominator there. How about 5/3 times 9. The 3 goes into 9 3 times. 3 times 5 is 15. So by multiplying by that least common denominator, we were able to cancel all the denominators. No more fractions, which is a lot easier. If I gave you this problem to solve rather than that, you'd have much less trouble. That's why it's worth it to multiply through, get rid of the denominators, and then solve that. And that one we would subtract 4x. -3 equals 5x plus 15. Subtract 15. -18 equals 5x. Divide by 5. And same answer. But if you can avoid dealing with fractions, you probably want to avoid dealing with fractions. Yeah. Okay. Well, yeah, 9 times 5 would have been 45, and then divide by 3 is 15, right? So again, rational equations include fractions. Remember, rational think fractions. You're going to take an SAT someday, and it will be part of it. SAT. I'm saying someday when you take the SAT, assuming that you do, they'll use that word rational and think that you know what it means. It means fractions, or any number that could be written as a fraction. Like I said, in the book, that last problem I did, they included under the rational equations because it had fractions in it. But what it did not have is like this. It did not have variable expressions in denominators, which makes it kind of a different thing. Okay. So the basic procedures to solve a rational equation, this is somewhat review, but we usually, these are the problems we miss the most on the SOL by far. The first step would be factor denominators. In this problem, there's only one denominator that you can factor. That's the x squared minus 4. How does x squared minus 4 factor? Yeah, it's a difference of squares, which you can kind of, most of these problems, they're not set up to be overly complicated. You can kind of see where you're going with that, right? So here's 1 over x minus 2 equals 3 over x plus 2 minus 6x over x plus 2 times x minus 2. Oops, that was wrong. Okay, now we need to find the least common denominator, which we did here when there was no variables in the homework. We broke it down into its prime factors. That's what we did by factoring the expressions here. The least common denominator, find LCD. Right. The LCD should be every factor that you see to the highest power you see it. Right. So in our case, the LCD is, okay, this has got a factor of x minus 2 in it. This one has a factor of x plus 2 in it. The next one has x plus 2, but we already have that. It has x minus 2, but we already have that. Okay. But since both of these are raised to the first power, everywhere those factors are first power, then that is the least common denominator. Okay, so find the least common denominator, then multiply by LCD. And let me change colors here. So multiply every term by the LCD. This first term, multiply by x plus 2 times x minus 2. Multiply x plus 2 times x minus 2. X plus 2 times x minus 2. Right. Step 4. Just like we did in the last problem. cancel denominators. So in this first term, there's an x minus 2 in the numerator, there's an x minus 2 in the denominator, cancel. In the next term, there's an x plus 2 in the numerator, there's an x plus 2 in the denominator, cancel. In the last term, this x squared minus 4 is x plus 2 times x minus 2, so that cancels with both of those. Okay, so what's left? In the first term, x plus 2. The next equals 3 times x minus 2 minus 6x. So once you've multiplied to get rid of the denominators, what's left is something simpler, right? At least it's not a rational equation anymore. It may be more difficult than that. It may be more, this is a linear, which we know is a fairly easy one to attack. But it could be quadratic. Whatever is left, solve. Solve what's left. So this becomes x plus 2 equals 3x minus 6 minus 6x. Combine like terms on the right, which are the like terms. The 3x minus 6x, right? So x plus 2 equals negative 3x minus 6. So that's a straight linear equation at this point. Which term would you add next or subtract? What would we recommend to do? Add 3x, right? Add 3x. Generally, start with the variables and move the smaller of the two terms. Which is smaller, 1x or negative 3x? Negative 3. Because it's on the number line, negative 3 would be to the left of 1. Even though 3 looks bigger than 1, that's a negative 3. So add 3x. That's 4x plus 2 equals negative 6. What should I do next? Subtract 2. So now I got 4x equals negative 8. Last step, divide 4. X equals negative 2. Okay, let me do this. I don't know how to do this. Oh, maybe there is there. I want to get as much of it in there as I can. Now, there is one last step. Remember what we said on the linear? Yes, you can check. Somebody got a phone here? Is it my, okay. They got to wait. Remember how the linear we said you could check? The thing about rational equations, you have to check. Okay, because notice what would happen here. If I tried to start, if I had negative 2 as my solution, what would have happened if I plugged in a negative 2 in the original equation? You're dividing by 0, and you can't do that. So you do have to check. And you're checking for exactly that kind of situation. And when you find an answer that you solved in every which way, you solved it correctly, and you get an answer that doesn't check, that answer is called extraneous. So you're checking for extraneous solutions. Right, and this extraneous, because the 3 over x plus 2 equals 3 over 0 equals undefined. Good. Good. Okay. Okay, here's another rational equation, right? They're fractions. There's definitely a variable in the denominator. If I was going to find an LCD, I would write down every factor that I see the most times that I see it. Okay, so what is the factor in the denominator on the left? The whole 5x plus 6, right? And what is the factor on the right? Just the 2. Right? And now I would multiply everything by that. Okay, so if I multiply on this side 2 times 5x plus 6, and on this side times 2 times 5x plus 6, what happens? The next step would tell me to cancel denominators. And do they cancel? Yeah. I mean, I can cross out now. I could cross out the 5x plus 6 with the 5x plus 6, the 2 with the 2, and I would be left with 2 times 10x plus 3 equals 5x plus 6. But here's the thing. That rational equation is actually kind of a special type because it's only one fraction equals one fraction. There's another way to solve it. What do you normally do to solve an equation like 1/2 equals x over 4? What's the method to solve? Cross multiply. Now, you can't do that like on the last one where is it? You have more than one term on a side, you can't cross multiply. But if you actually are starting with a problem that only has one fraction equals one fraction, then you can do the cross multiply. And you probably think of that easier. You'll think that that's easier. In the end, notice when I do the cross multiply, 2 times 10x plus 3, that's this. 1 times 5x plus 6, that's that. So it accomplishes the same thing, whether you think of it like a cross multiply or whether you do it by multiplying by least common denominator. Okay, let me do this. Okay, solve. What do I have to do first? 2 times 10x, 2 times 3. 20x plus 6 equals 5x plus 6. Is that right? 20x plus 6, 5x plus 6. Okay, subtract 5x. So I got 15x plus 6 equals 6. Then subtract. So 15x equals 0. X equals 0. I'm not sure what you got. Like here? No. Why can't you want to go like 5 goes into 10 2 times? No. Remember, the only time you can, in simplifying a fraction, the only time you can cancel the factors is when they are factors of the whole numerator and whole denominator. Like this 5 here, it's not like 5 parentheses something. So it's not a factor of the whole numerator, denominator. So you can, you can't just like take one term in the numerator and cancel with something in the denominator. We're looking for entire factor. It has to be a factor of the whole numerator, whole denominator. That's when it cancels. I mean, take, for example, 6 over 8, right? That would be 3 times 2 over 4 times 2, right? Because the 3 and 4 are factors, or the 2's are factors, they cancel, right? But I couldn't do like, let's say 5 over 7 equals 3 plus 2 over 5 plus 2. I can't go in there and say the 2's cancel because those 2's are not factors, right? They're being added, not multiplied. I mean, 3 over 5 is 0.6. 5 over 7 is not 0.6. You just changed the value of it. 3 over 4, 0.75. 6 over 8, 0.75. You can cancel common factors. You can't just take terms, okay? That's a common mistake we make that we shouldn't be making. Okay. Okay, quadratic equations mean the highest power is 2, right? And the general equation, the standard equation is ax squared plus bx plus c equals 0. Where the one thing you know for sure is a does not equal 0, because if it did, you wouldn't have a squared term. Right? It's okay if b equals 0 or c equals 0, but a has to not equal 0, or else you don't have a quadratic. Right? Quadratic means the highest power is 2. Quadrato means squared in Italian, Latin, quadrato. That's why they use that word. Otherwise, why wouldn't they just call it squared? They do, just in a different language. So quadratic equations, there's a whole lot of ways to solve them, which we're not going to do all of them here today. You know, okay. Good. Okay. So factoring, extracting square roots, we will do some of that. Completing the square, we're not going to actually use as a way to solve. We'll do it later in this class. We will have times when we do completing the square. The quadratic formula, everybody's familiar with? The quadratic formula is derived by completing the square. So actually, when you use quadratic formula, you're kind of using completing the square already. It's part of it. And then graphing is not part of what they present in the lesson now. I presume later when we get to that part of the review, there will be more solving by graphing. I'll show what it means, but we're not going to do any solve by graphing, for which you definitely would need a calculator, right? Then you'd have to like put it in the calculator and use the calculator functions to do it. But the main ones that we really care about here, factoring, quadratic formula, and which is the one that always works. Quadratic formula always works, right? There are times when you can't factor a quadratic expression. There's times when graphs don't cross the x-axis, so you can't see the solutions. It doesn't mean there aren't any. It just means they don't show up as real numbers on the real number line. Okay. Good. So the most basic kind of factoring, the one we actually probably do the best with, is when you have 3 terms, which means trinomial, and the number in front of x squared is a 1. When that's the case, then you have to go through this thought process. You say, what are the factors of -6 that add up to -1? What are the factors? I mean, 6 is either 1 times 6 or 2 times 3. Because they add up to a negative number, it must be that the bigger of the two is negative. So it's either 1 times -6 or 2 times -3. Which one of those adds up to -1? This one right here, right? 2 plus -3 equals -1. So what do you do with that? You go immediately to x plus 2 times x minus 3 equals 0. Right? It's a one-step factoring process, right? You don't need to break up the middle term and group the first two and the last two, because that number is 1. It's a one-step process. Okay, now you have to Yeah, the only way you make a 0 through multiplication is you start with a 0. So that means either the factor x plus 2 equals 0 or the factor x minus 3 equals 0. So you make those equations. X plus 2 equals 0. X minus 3 equals 0. And you solve. In this one, x equals -2. This one, x equals 3. And because this is really somewhat of a review, you know, if you identify that immediately here, that's fine. Most of the time we would. You would just go -2, +3, done. But if you need to, set each factor equal to 0, solve for x. Now, notice that what we started with here, you couldn't isolate the variable because there was an x squared term and an x term. They're not like terms. I can't put them together. So there's no way to like isolate the variable on one side. But using this property, which is called zero product property, but this book calls it zero factor property, you can isolate the x. That's why you factor. So you can isolate the x. Is there a question? How about this one? Solve by factoring. I think we did this one before. It's the difference of squares, right? So x plus 2 times x minus 2 equals 0. Which term is this one missing? The x term, right? Which means that the x term has a coefficient of 0. So you could actually think that same process that we did on the first one. What two numbers, their product is -4 and their sum is 0? 2 and -2. There you go. Okay, now what are the answers? -2 and 2. Done. Okay. Now, am I going to start factoring the left-hand side already? What do I have to do before I can do that? Remember, the standard form is ax squared plus bx plus c equals 0. This one doesn't equal 0. So how are you going to make it equal 0? Subtract 6. So now we have 2x squared minus 3x minus 5 equals 0. Now, this is the hardest factoring that we do because the coefficient of x squared is not 1. Now we got to go through 6 steps to get the right answer, right? Do you remember what the first step is? 2 times -5 is -10. Okay, what are the factors of -10 that add up to -3? Okay, well, let's see. 10 is either 1 times 10 or 2 times 5. Because they add up to a negative number, the bigger number is negative. The smaller number is positive. So it's either that or that. Which one of those add up to -3? Right, this one, 2 plus -5 equals -3. So we want 2 and -5. What do we do with the 2 and the -5? Put them, break up that -3x. Instead of calling it -3x, make it 2x squared. Does it matter which goes next? Do I have to say 2x minus 5x, or could I say -5x plus 2x? You can go either way. Normally, if you have a plus and a minus, start with the minus. Minus 5x plus 2x minus 5 equals 0. Then what? Okay, then you're going to group the first two and the last two. Now, if I would have split that up, or if I would have written 2x minus 5x, it would have looked like this. 2x squared plus 2x minus 5x minus 5 equals 0. And then when I grouped, 2x squared plus 2x minus, and that minus is in between the parentheses, 5x plus 5. Right? Then, because you have a minus in front of the parentheses, you have to flip the sign, because minus times plus is minus. You're not trying to change anything. You know, when you make sure that it's actually going to be a plus in between, you don't have to worry about that. And to me, if I was just doing this myself, I probably would not have written this on a new line. I would have just grouped it right there, because I don't have to worry about flipping signs. But anyways, now factor. What's the common factor in the first set of parentheses? X. X times 2x minus 5 plus 2x minus 5. Right? There's nothing to factor in the second set of parentheses. But if there was, we would do it. Now we've got a 2x minus 5 in both terms, in this term and in this term, separated by a plus sign. So factor it out. 2x plus 5. Right? What's left if I take 2x minus, that's supposed to be a minus, right? What's left if I factor the 2x minus 5 from here? The x, right? If I divide out the 2x minus 5, there's still an x there. Now here's the tricky one. What's left if I divide out 2x minus 5 from 2x minus 5? 1. Right, so that is plus 1. It's not 0. It's not 0. There's a 1. Just think of it like 2x minus 5 divided by 2x minus 5. Okay, now we've factored it. So in order to make a 0 through multiplication, then it must be that one of these two equals 0. What value of x would make the first factor equal 0? Yeah, so we're going to say x equals negative 1. That's one of them. And then this one, right? If you're not sure, you know, then set it up as an equation. 2x minus 5 equals 0. 2x equals 5. X equals 5 halves. Now, you might recognize that without doing all that. I mean, just imagine if you put a 5 over 2, the 2's cancel, and then the 5 minus 5 is 0. But you don't want to just look at it and say, oh, the answer is 5, because you see the minus 5. Because it's 2x, it's not x. That's why it's not 5. Yeah. Here? Well, I factored the 2x minus 5 from both of these. And then this one, when I take 2x minus 5 from this, what's left? Just the x. That's this. When I take 2x minus 5 from this, what's left is a 1. Because that's the whole thing, right? 2x minus 5 divided by 2x minus 5, it still leaves a 1. It's not a 0. Does that explain it? I mean, when you do this method, every time what you get in the parentheses at this step will be the same thing. So to go from this step to this step, that thing in the parentheses, that's one factor. And you just have to say, well, what's left when I take that away from both of these? X plus 1. Okay. How about solving this one by factoring? Do we need to go through any of that thought process? What two numbers? Product is this, sum is that? What kind of factoring would you do on something like that? It's not a difference of squares. This is the most basic kind of factoring, greatest common factor. Can you see any common factors between those two? 3x, right? So factor out the greatest common factor that you see. What's left when I divide out 6x squared divided by 3x? 2x. And again, here it is. 3x divided by 3x is 1, minus 1. So we usually, after we've done all the more complicated kinds of factoring, and then we get to this one, we're stumped. We don't think of the most basic, which is just take out any common factors that you see. Okay, now, again, you could set this up. 3x equals 0 and 2x minus 1 equals 0. Solve for x. Divide by 3, x equals 0. Right? If 3 times a number equals 0, the number must be 0. And this one would be 2x equals 1, x equals 1/2. I'm sorry it's going on longer than I thought today. I did not expect. And I cut this in half. I'm doing it in 2 days. I thought it would be less than this. Okay. Okay. Thanks, Damien. This is what they mean by extracting square roots. When you have the expression doesn't have a linear term, doesn't have the x to the first, the only x is in the squared term, then you can actually solve it by solve for the x squared, add 4 to both sides, and then take the square root, right? So when we take the square root, x equals plus or minus 2. Don't forget the minus, right? Plus 2, minus 2, also known as plus or minus 2. Remember, we solved that exact one by doing difference of squares. X plus 2 times x minus 2. And we got the 2 and the negative 2. Okay. Okay, here's one. Another, you could solve by extracting square roots. First, you got to solve for the x squared. What do you need to do? Divide by 3. Right? Isolate the x squared. X squared equals 12. Take the square root of both sides. X equals plus or minus the square root of 12, also known as plus or minus 2 times the square root of 3. Good. Okay, here's another. Take square root, as long as what's on the left is a perfect square, then take the square root of both sides. What's the square root of x minus 1 squared? X minus 1. And the square root of 10. And then we haven't solved for x yet. Add 1. Add 1. Actually, that's a plus or minus the square root of 10. So that is x equals 1 plus or minus the square root of 10. Which leads to quadratic formula. Quadratic formula, I know you know, you're going to be given it, or I'm not asking to memorize it, but if you have it in front of you, you should know how to use it. Right? So the quadratic formula is all about A, B, and C. You got to know what the A, B, and the C are. Right? The A, B, and C are the coefficients of the squared term, the linear term, and the constant term when it's in standard form. When it's written, it's simplified, highest degree term on the left, descending order of powers. Okay, I think I got 2 of those. Good. It's also here if you need to write it. So, for example, in this problem, what are the values of A, B, and C? Right, this is the A, this is the B, this is the C. Right, so plugging in that formula, x equals 2 plus or minus the square root of 2 squared minus 4 times 3 times negative 10 divided by 2 times 3. X equals 2 plus or minus, right? What's 2 squared minus 4 times 3 times negative 10? What's 4 times 3 times 10? 4 times 3 is 12. 12 times 10 is 120. Is it positive or negative? Minus times minus makes it positive. So it's actually going to be 2 squared, 4 plus 120, 124. And then, holy moly, 34. You know, this 124 is 4 times 31. Yeah, 4 times 31. So that's 2 plus or minus 2 times the square root of 31 over 6, which is 1 plus or minus the square root of 31 over 6, over 3, sorry. Right, 124 is 4 times 31. And the only difference between this example and the next example is the last one. Good? First of all, in this, we're going to have to plug in. Those numbers are kind of big, aren't they? Do you see any common factors in all those terms? There's a 2 at least. So if you divide out a 2, right? 2, 2, 2. At least the numbers will be smaller, right? That'll be 9x squared minus 24x plus 16 equals 0. They'll make all the calculations easier anyways. Now we plug in. This is the A, this is the B, this is the C. So notice what happens here. We'll get x equals negative 24 plus or minus the square root of negative 24 squared minus 4 times 9 times 16 divided by 2 times 9. Now, I know you don't have calculators in your hand to do this for yourself. But if you did this negative 24 squared minus 4 times 9 times 16, it's 0. It's 576 minus 576, 0. Which means our answer is positive 24 plus or minus 0 over 18. So what's the difference between adding a 0 and subtracting a 0? It's the same thing. So sometimes if you get a quadratic, you're solving it, you actually get the same number twice. And it's exactly when this kind of thing happens. So 24 over 18 is 4/3. So again, what made that problem unique was just that when you did the b squared minus 4ac, you got 0, which meant one answer, not 2. So again, we did the linear, and we did the solving quadratics by factoring, extracting square roots. We did not do the completing the square, but we did the quadratic formula.